Hi, this is Naveena from the Department of Cybersecurity in the Institute of Aeronautical and Engineering. And today, my concept video is regarding the congestion controlling algorithms. In this, and I want to discuss the types of the congestion control algorithms and the two types of congestion control algorithms like open loop and the closed loop. Under this, the retransmission policy, acknowledgement policy and admission policy, as well as coming to this closed loop, back pressure and chota pressure and implicit signals and explicit signaling. And under this, the window policy and the discarding policy. And after that, coming to that, and mainly the two types of congestion controlling algorithms we need to determine or identify here, like the Leafy bucket algorithm and the token bucket algorithm. And after that, and what are the types and advantages and disadvantages of the Leafy bucket algorithm. And while incoming the packets are taking the packets or forwarding the packets from one source to the destination, and while it reaches to the destination node, how the transformation will be taking place from one source to the another source by means of a Leaky bucket algorithm. And coming to this, and the two tasks of the congestion control algorithm, the techniques of a congestion controlling algorithms are the Leafy bucket algorithm as well as the token bucket algorithm. And after that, mainly the two types of congestion controlling techniques like open loop congestion controlling techniques and closed loop congestion controlling techniques. And coming to that, mainly the differences between the open and closed congestion controlling techniques. So here, and first of all, I want to define and I want to discuss and what do you mean by a congestion? What a congestion defines and how you can make a definition of what do you mean by a congestion. So congestion means it causes a choking or any disturbance while transmitting the data packets from one node to the another node. And if you can define or the heavy flow of a data packets while transmitting from one node to the another node. Like if you can take the example of, since many videos and I am telling the taken the consideration of one node, that is the node 1, this is the node 2, and when a data packet can able to transmit from one source to the another destination, so there should be a heavy flow of traffic of packets. They are ready to reach that destination node as early as possible without getting the acknowledgement to the source node of 1 or the sender of a 1 node. So that situation, what we can call it as a congestion. In another way, if you can define the congestion, it may causes the choking of the communication medium. That means disturbance. What do you mean by a choking? It will nothing but the disturbance or discardness. What do you mean by discarded or disturbance? Disturbance of a communication path while transmitting the data packets from one node to the another node. So if you can truly define the congestion causes choking of the communication medium when too many packets are displayed in a method of the subnet. The subnet's performance degrades. Hence, a network's communication channel is called as a congested if packets are transferring or sending the path and experiences the delays mainly over the path propagation delay. That means, as I am telling you and explaining that while transmitting the data packets in a flow mode one by one, like in this path already the selected path, if you can identify, the delay must be taken while reaching the packets to the destination end without getting a certain acknowledgement of a one packet to the node 1. That condition, what we can call it as a congestion. So let us consider, if you can describe or if you can assume one example related to the congestion and how to understand a simple logic of how the congestion will be taking place. So imagine a bucket with a small hole in the bottom. Suppose if you can take the example of a bucket with a small hole will be taken in the bottom. If you can identify, no matter at what rate of the water it might be filled with how much the capacity of the water enters into the bucket, the outflow is at a constant rate. That means when the bucket is full of water, additionally the water enters, spills over the sides and it is lost parallelly. Similarly, the each network interface contains a leaky bucket and the following steps are involved in the leaky bucket algorithm mainly, and how many types of algorithm will be described by means of this type of explanation of the congestion control. Let us discuss one by one. There should be mainly the two types of algorithms they need to determine. The first one is the leaky bucket algorithm. Second one is the token bucket algorithm. And the two types of techniques means open and the closed congestion controlling techniques. So when you can take the example, if a bucket is having the hole, whenever you are pouring the water, it will be coming parallelly. How much water it will be taken inside, the capacity of water we could not identify while you are filling, the water is coming outside. Like that only the leaky bucket algorithm means how it will be happen and how will determine by means of a congestion controlling algorithm, and what are the advantages and disadvantages while we are discussing with leaky bucket algorithm. Mainly they are the congestion controlling algorithms can be classified into two types. The first one is open loop congestion control algorithm. Second one is the closed loop congestion control algorithm. And under the open loop, and again it will be divided into mainly the three types. The first one is retransmission policy. Second one is acknowledgement policy. Third one is admission policy. And again the open loop can be divided into window policy, and second one is the discarding policy. And again coming to this the second section of a closed loop, again it will be divided into the four types. What we can call it as a back pressure, choke packet, implicit signaling and explicit signaling. Mainly these are all the types of congestion control methods or congestion controlling techniques. Let us see one by one and how the these open loop and the closed loop, and what are the main two types of congestion controlling methods, or what we can call it as algorithms, and what are the types of advantages we will have. Let us see one by one. First of all, the congestion controlling algorithm mainly it will be consisting of the two types. What we can call it as the first one is leaky bucket algorithm. Second one is the token bucket algorithm. Mainly congestion controlling algorithm consisting of the two types of algorithm. The first one is leaky bucket algorithm. Second one is token bucket algorithm. These are the mainly the two types of congestion control algorithm. So there is a two congestion controlling algorithms which they should be followed as. The first one is the Leafy bucket algorithm. This means the Leafy bucket algorithm discovers its uses in the context of network traffic shaping or rate limiting. That means this algorithm allows the controlling the rate at which a record is injected into the networking and managing the burstness in the data rate. That means the sending of the data packets from one node to the another node. And if you can take the another point, a Leafy bucket execution and a token bucket execution are predominantly used for traffic shaping algorithms. They can be recognized or identified or termed as a traffic shaping algorithms. This algorithm is used to control the rate at which the traffic is sent to the network and shape the burst traffic to a steady traffic stream. Suppose if you can take one example, suppose to our highway route, and some highways they are especially meant for the high level of the transport vehicles like and leyland lorries, and some the transport mode of vehicles which should be transported and they can take the luggage or carrying loads of materials from one place to the another place. So some highways they should be meant for the transportation of heavy load of vehicles, and some roads and some highways they are meant for the general mode of transmission. Like that only here the leaky bucket is determined, and the main purpose of this algorithm used to control the rate at which the traffic is sent to the network and shape the burst traffic to a steady traffic stream. That means it will be defined and determined based on the network and the flow of, based on the flow of a data packets, and how many packets, that means if you can able to define, suppose if you can take the two types of packets, this is the first one, this is the second one of packet, and these two type of packets if you can determine. So first of all, this path consisting of the heavy flow of data packets if you can take from one node to the another node, and second path if you can take the very slow level of or less flow of traffic or less flow of data packets in this second path. So the leaky bucket algorithm assumes or determines the rate at which the traffic is sent by means of a first path from one node to the another node, and it can able to differentiate the second path on which the data packets can able to transmit from one node to the another node based on a traffic stream under one network. This is the main the element or the concept which should be included under the leaky bucket algorithm. So, coming to that, the figure shows the leaky bucket algorithm. It will express the pictorial representation of leaky bucket algorithm like our bucket only. Suppose our bucket also will be having this model, and if it is any leakage here, any hole will be there. If you can pour this water like this only, so when how much the capacity of water it will be intake, or you are pouring, simply it will be coming by means of this hole at the bottom of this end. Like that only, this figure shows the leaky bucket algorithm. Like the leaky bucket algorithm, the incoming packets are like this only, that packet 1, packet 2, packet 3, packet 4, packet 5. So at the end of this network, and there should be a one hole will be identified. So whatever the incoming packets they have, this bucket have received, automatically they will be coming outside by means of a outgoing way, or by means of a outgoing packets only they will be coming outside. So like the water only, how many incoming packets will be there, those all incoming packets they will be coming outside by means of the hole which will be we have identified at the end of a one network. That is the main concept which should be included under the leaky bucket algorithm. And coming to this, in this algorithm, a bucket with a volume of, suppose if you can take with a volume of says B bytes, and a hole in the node's bottom is considered. Okay, if the bucket is null, it means a B bytes are available for the sake of the storage. So, and next point, if you taken that a packet with a smaller size, then considering the B bytes arrives at the bucket and will forward it to it. So, if the packet sizes increases by more than B bytes, it will neither be discarded or nor else the queued. So, if it is also considered, then the bucket leaks through the hole in its bottom at a constant rate of bytes per second. Like the water only, if you can take it, the example of a data packets, the data packets are assumed in the capacity of a water, how we can calculate it by means of a liters. Here, the data packets can be calculated by means of a bytes per second. That condition what we can call it as a bandwidth of calculating. That means the rate of bits or the data packets which can able to transmit it per bits per second. That condition what we can call it as a BPS. So hence the incoming is like that, and the outflowing if you can consider constant when there is any packet in the bucket, and 0 when it is empty. Suppose if you can take the above example, what this example illustrates or determines mean the leafy bucket algorithm, all the incoming packets if you are taking by means of a bytes, 1 byte, and here byte, and third byte and fourth byte, like that only if you can take. And if you can take all the data packets by means of a bytes only, whenever up to until unless if the data packets they are coming and filled by means of this bucket type of networking, this would be empty. Whenever, so this example or illustration says the outflow is considered constant when there is any packet in the bucket is 0 when it is unless and until if the incoming packets are not arrived, the bucket is 0. Whenever the incoming packets are coming or arrived, so the bucket is automatically and it will be discarded or not queued or sending the packets parallelly by means of an outgoing mode. So here if you can identify one point, this defines that if data flows into the bucket faster than the data flows out through the hole. That means here if you can take here how many data packets will be coming. So that mode of data packets, they will be going outside. This is the main logic of the leaky bucket algorithm. So how many data packets they will be coming, incoming, and they will be going outside. They will be going outside. Mainly, this is the main concept of including while you are discussing with the leaky bucket algorithm. And the disadvantages, mainly rather than the advantages, we have to identify or determine. Many disadvantages can be determined by means of a leaky bucket algorithm. Some of the disadvantages are, compared with the leaky bucket algorithm, they are inefficient use of available network resources. Based on the leaky bucket algorithm, it is determined that it is nothing but the inefficient type of algorithm and which is available for a one unable to complete the network resources. Here, and the leak rate is fixed parameter. Here if you can take or consider the leak rate is fixed parameter. In this case of the traffic, the volume is deficient. Here the volume is deficient. The large area of network resources such as bandwidth is not being used effectively. That here, and mainly the disadvantages are nothing but the leak rate is fixed. That means leakage means the incoming of the packets as well as the outgoing of the packets. Leakage means this. This is called the leak rate. And the bandwidth we cannot identify per second. Bandwidth means the transmission of the incoming packets or the flowing of the incoming packets into the bucket type of network. What we can call it as a network. And the incoming packets, those it will be coming into the bucket, that is nothing but the bandwidth. And here the outgoing packets, what we can call it as the flow of outgoing packets, what we can call it as a leak rate. So here, and the volume is deficient. Volume we cannot able to express or identified or estimated. Hence, the term what we can call it as by means of a volume is, it is deficient. And the larger area of network resources such as bandwidth is not being used effectively. And coming to that, the next points or the concept including the leaky bucket algorithm, it has a rapid output design at the average rate which should be independent of the bursty heavy traffic. And if you can explain it by means of a second point, in some applications, when large burst arrives, the output is allowed to speed up. This calls for a more flexible algorithm, preferably one that never loses information. Therefore, a token bucket algorithm finds its uses in network traffic shaping or unlimiting of the packets either by means of inflow or outgoing protocol. So it is a type of a control algorithm which indicates when traffic should be sent or about to make the transmission from one node to the another node. This order comes based on the display of the tokens in the bucket. Hence, the bucket contains the tokens. Each of the tokens defines a packet of predetermined size. A token is nothing but like a data packet and consisting of a message, information, and which is ready, able to transport from one sender to the another receiver. The tokens in the bucket are deleted for the ability to share a packet. So when a tokens are shown, a flow to transmit traffic appears in the display of the tokens. No token means no incoming of packets and no flow of sending the packets, it seems. It should be identified when there is no token means no flow sends its packet. Hence, A flow transfers traffic up to its peak burst rate in good tokens in the bucket. So hence the leaky bucket algorithm does not allow individual flows to burst up to the port speed to effectively consume network. So this is about the description or the advantages and the disadvantages of the leaky bucket algorithm. So coming to the token bucket algorithm. This is the second type of congestion control algorithm techniques, as we have already seen related to the first algorithm technique, what we can call it as a leaky bucket algorithm, and second one is the token bucket algorithm. The leaky bucket algorithm has a rigid output design at the average rate of incoming the packets and as well as the outgoing independent of the bursted traffic, and it follows or it allows rigid output design. In most of the applications, when large burst means that arriving the data packets in a heavy flow, that what we can call it as a burst arrives. The output is allowed to speed up. This calls neither by means of a flexible algorithm, preferably one that never loses the information. It will be reached to the destination. Therefore, a token bucket algorithm finds its uses in network traffic shaping or rate limiting or bandwidth. Those are same, rate limiting or bandwidth. That means rate limiting means the rate of transmission of the data packets on a particular path per bits per second, and bandwidth also the transmission of the data packets per bits per second on a particular logical connection which should be established by means of a one network layer. So hence, and it is if you can define the token bucket algorithm, it is a control algorithm which indicates when traffic should be sent. This order comes based on the display of tokens in the bucket, as the name mentioned here and initially. That means the message passing or the data packets, it should be sending or able to transmit it by means of a token only. Hence the name, it will comes token bucket algorithm, and here the display of the tokens in the bucket we have to identify it. So like this leaky bucket algorithm, we have to identify the token type of display of the tokens in the bucket. That means like this only. So in the bucket, we have to identify the number of tokens which should be displayed. We have to identify it by means of a token bucket algorithm. The bucket contains tokens. So each of the token defines a packet of a predetermined size. And what makes the difference between a datagram and a data packet and a data bit? All these are holding or and having a type of message or a communication which should be sent from one node to the another node. So here, and a token, if you can define, means it is a size of a packet with predetermined size of data, what we can call predetermined size of data. So the bucket already contains the token. So each token defines a packet. That packet should be with a minimum of predetermined size of a data. Here, and if you can explain or elaborate the token bucket algorithm, the tokens in the bucket are deleted for the ability to share a packet. When tokens are shown, a flow of transmit traffic appears in the display of the tokens. No token means no flow of incoming packets will be arrived and no flow of outgoing of packets we should identify. When there is no tokens, we can able to identify by means of a particular bucket. Hence, a flow transfer and traffic up its peak burst rate in good tokens in the bucket. The leaky bucket algorithm does not allow individual flows to burst up to the port speed to effectively consuming on the total network technology or topology. So here, and we have to identify mainly it is a controlling algorithm on which a particular traffic should be sent, and display of the items, that data rate of a bits, they should be transmitted from one node to the another node by means of a bit. And here the burst flow of arriving will be identified. The burst flow means how much the data packets they can transmitted in a heavy flow from one node to the another node, that what we can call it as a burst arrives. Here, so display of the tokens we might be identified in the bucket, and the bucket, all the total bucket containing the tokens. So each of the tokens defines a packet of predetermined size. So that predetermined size of data packets only can able to arrive, and they can able to transmit it under the particular path of concerned network subnet. This is mainly token bucket algorithm. So coming to that, when tokens are shown, a flow to transmit traffic appears in the display of tokens again, and I need to draw the diagram of related to the one bucket of token burst and algorithm. Like this is one of the buckets, as I have already explained in the token bucket algorithm. This is one of the bucket, and here the data packets are transmitted or segregated by means of a tokens. The tokens of data packets must be transmitted from one node to the another node, Here, when tokens are shown, a flow to transmit traffic appears in the display of the tokens. No token means no flow of sending the information as well as and reaching those information to a concerned destination we have to identify. There is no flow means no arriving and no receiving and no sending the packets we have to identify. Hence, a flow transfers traffic up to its peak burst rate in a good tokens in the bucket. That means if it is coming all the tokens, it will be coming very heavily or very rushly if you can take by means of this token bucket example. Hence, a flow transfers the traffic up to its peak burst rate in a good tokens in the bucket. So, it can receive this bucket, it can receive all the type of the data packets which should be in the form of a predetermined size, like whatever the packets it will be coming, it will receive all the data tokens in the form of a concerned bucket. How many tokens those will be coming? This bucket, they will take all those incoming tokens and they will identify the peak burst rate in a good tokens in the bucket. Whenever a bucket receives all the tokens, then they will identify and determine how many type of good tokens will be there. Those good tokens, they will have it or hold it, and remaining, if there is any discarded tokens or any error corrupted tokens will be there, those will be discarded. That is the token based congestion controlling technique. And here if we are explaining or defined by one point, thus the token bucket algorithm adds a token to the bucket each 1 per second. How is the transmission rate or the flow of a token? Each 1 bit per second. So the volume of the bucket is, the volume means this one, the volume of the bucket is V tokens. When a token appears, that means when a tokens are coming and the bucket is completing, whenever all this bucket is filled with these tokens, the token is discarded. Whenever, so the bucket is empty, and if it will be taking all the tokens parallelly until and unless the bucket is filled. If a packet of n byte appears and n tokens are deleted from the bucket, the packet is forwarded to the network. If a packet of n byte means this is nothing but the leaky bucket algorithm. This is for the n tokens means token bucket algorithms are deleted from the bucket, the packet is forwarded to the network. Here, what is the concept and what I need to explain again means here, so the bucket is about to filling all the data tokens arriving one by one. Whenever the bucket is filled with a peak burst rate of good tokens, so after that it will be filled heavily, and whenever it will hold the good number of n tokens and are deleted from the bucket, whenever it will be filled with good number of tokens, then only if it will be having or holding the number of tokens in the bucket, each one per bit second, then only it will receive all the tokens which will be coming, which would be coming from the previous layer in the network layer. So it will receive all the tokens by means of this bucket, and after that, if there was any error detected or any corrupted tokens will be there, those tokens will be discarded, and the good number of tokens or what we can call the packets is forwarded to the remaining network layers. That is the main concept which should be included by means of a token burst congestion controlling algorithm. So coming to that one, and if you can extend it, the concept of a token bucket algorithm, when a packet of n bytes appears but fewer than n tokens are available. Suppose if you can take the example. So n tokens are removed from the bucket from the back end in such a case, and the packet is considered non-conformant. The non-conformant means the packets can either be dropped or queued for a subsequent transmission. As I already explaining, whenever if a one bucket can able to receive the number of tokens at the rate of 1 bit per second, or 1 data rate per second, so either the other may be dropped or non-queued for subsequent transmission when sufficient tokens have accumulated in that bucket. So they can also be transmitted but marked as being non-conformant. The possibility is that they may be dropped either by means of subsequently if the network is overloaded one by one, if it will be loaded by means of a number of buckets filled with a tokens. And here, so mainly up to now we have already seen that leaky bucket algorithm as well as the token bucket algorithm. Here, and mainly there are two types of congestion controlling techniques will be there. That is nothing but the open loop congestion controlling technique, and second one is the closed loop congestion controlling technique. So the first one is the open loop congestion controlling technique. So here, if you have seen, the first one is the retransmission. Retransmission means the sender resends the packet whether that is lost or discarded or corrupted. That is the main concept of retransmission. And retransmission in generally may increase the congestion in the traffic, or hence it needs a good retransmission policy or the timers to optimize efficiency to prevent the congestion buildup. And second one is the windowing. Windowing means the types of window used. The two types of windows will be there. The selective repeat window is better than the go back n window to prevent the duplication arriving of the data packets in a good idea of data. So here, and the third one is ACK. It's also affects congestion because it is a part of a loading the data packets either by means of a tokens or a bytes. So whenever a receiver or node 2 or a destination host may send an ACK only if it has been a packet to be sent or specially timer and expires or may decide to ACK only n packets at a time. That means it will reflects, the ACK will reflects or identified or needs to reveal it is a special timer. ACK is nothing but the special timer which can reflects or tells to the sender whenever the n number of packets, you need to send the n number of packets at a particular time on a particular path. If more than that of n number of packets will be arrived and I don't have any acknowledgement, I don't want to give any acknowledgement provided by me to you in a consequent time. That is the main concept of ACK. Coming to that, the last one is the discarding. Need good discarding policy to not to harm the integrity of the submission. That means, example, the audio to packet discard less sensitive packet. So the quality of the sound is still preserved or highly motivated by means of its audio packet discarded less sensitive packet. Example of one open loop congestion control is nothing but audio packet. And coming to that, the second one is the closed loop congestion control packet. It is nothing but, and here the two types of the congestion controlling algorithm techniques will be there. The first one is the open loop, second one is the closed loop congestion control here, and back pressure will be there. Next one, the choke point. Next one, the implicit signaling. Next one, the explicit signaling. So here, back pressure means when a router is congested. Router means what a router? A router can able to link many hosts, more than one hosts. So either by means of those connections or either by means of a LANs or WANs, a router can able to connect 2 or 3 devices parallelly at a time. So when a router is congested, suppose if you can take the example of a router by means of a LANs, so this router is congested. It can inform the previous upstream router to reduce the rate of outgoing packets. The action can be recursive all the way to the router before the source node can transmit the data packets to its destination host in a particular time. That is nothing but the back pressure. What I mean to explain, the main elements or the points under the closed loop congestion control means when a router is congested, it can inform the previous upstream router to reduce the rate of outgoing packets. So rather than if you are thinking the rate of outgoing packets, meanwhile it doesn't want to take the rate of flow of incoming packets. That is nothing but they don't want to hold up or held up with a back pressure. That means they need to send on a one path how many data packets they will be coming in a consequent way. So they need to send the rate of outgoing packets in that mode only by a concerned acknowledgement. So for that, so the action can be recursive in all the way to the router before the source can able to transmit the number of data packets from one node to the another node. And coming to that, the choke point, a packet sent by a router to the source to inform it to the congestion. This type of control is similar to ICMP's search quench packet. That means before that a packet is ready to transmit it or able to travel on a one particular path, it will be determined the route by means of a one router to the source router. It will be informed previously the type of congestion, whether that route will be having the free flow of traffic or it will be affected with any congestion. That should be determined previously by means of a router. Hence, that router, what we can call it as a IMPS source quench packets. That means the packets, whenever they have to determine or pre-knows or pre-knowing of that whether the router, that the particular route or a logical connection is free flow to the transmission of the data packets or whether those will be congestion or congested. So that type of pre-transmission or the pre-source route of condition, what we can call it as a ICMP source quench packet. A packet, whenever they should know the type of path and which type of path they are able to transmit from one source to the destination, and whether that path will be having the free flow of controlling the free flow of data, or it will be any congestion control. So those type of the technique will be determined by means of a router, and hence that condition what we can call it as a ICMP source quench packet. And coming to that implicit signaling, a source can detect an implicit signal concerning congestion and slow down its sending rate. For example, the mere delay in receiving an acknowledgement can be signal that the network is congested. As I am telling and explaining you in my previous concepts, what I mean by congestion means arriving the data packets continuously, the flow of arriving the incoming data packets continuously to the destination node or to the receiver without getting the acknowledgement of a one destination to the source router or to the source node. That condition what we can call it as a implicit signaling. And coming to that explicit signaling, routers which have been experienced congestion can send an explicit signal, that what we can call it as the sending of a bit in a packet. For example, to inform the sender or the receiver of a congestion. That means explicit signal means, first of all, before the transmission of the flow of data packets, first a routers can able to experience to know the condition of a congestion. They can able to send one data bit, single bit of packet to check the route, whether that route should be in a congested or it will be any free flow. Whether that route is free means they can able to transmit the number of n type of packets in that particular path. If it is a congestion oriented, so they will take in either by means of a second diversion or they will able to select the second path. This is nothing but the explicit signaling, and means that one type of simply one bit can able to send by means of a router to know the condition of the check of the flow control of the data packets, whether that route is a congestion oriented or it is a free flow of the data packets from one node to the another node. That condition what we can call it as a explicit signaling. And here that backward signaling, a bit can be set in a packet moving in the direction opposite to the congestion, indicate the source. Here back pressure we have already seen. Here backward signaling means a bit can be set in a packeting moving in the direction opposite to the congestion. Backward signaling means, as I have already explaining to you, one data bit can send to check the condition of a flow of traffic, whether it is a free flow of traffic or it is a congestion oriented. So whenever the bit can able to transmit on a particular path, checking the condition of the total path, whether it should be a congestion oriented or a free flow, it will be coming back and giving to the direction to a particular router, whether it is will be a congestion means congestion oriented or it will be free flow means the path is totally free flow. That condition what we can call it as a backward signaling. These are the main elements or the subtopics which should be included under the closed loop congestion controlling algorithms. Coming to that, and I want to make the differences that are what else we can call it as the review of based on the two types of difference. What is the difference between open loop congestion control and the closed loop congestion control? So, and if you want to take the smaller differences between and up to our completed topics like open loop congestion control and the closed loop congestion control. In open loop congestion control, policies are applied to prevent congestion before it happens, and it is meant for before the congestion it will be happened, we need to apply some policies to prevent that congestion. That condition what we can call it as a open loop congestion control. So coming to that, the closed loop congestion control mechanism, they try to elevate the congestion methodologies after it happens. That means they try to implement or elevate those type of congestion techniques and congestion methods, what we can call, whenever after the congestions it will be or the error detecting or congestion it would be occurred. That is the main difference between the open loop congestion control and the closed loop congestion control mechanism techniques. So here again I need to review the differences between the open loop and the closed loop by means of the open loop and the main subtopics, the concepts which should be included by means of a open loop is nothing but the retransmission policy, window policy, acknowledgement policy, discarding policy and admission policy. Coming to the closed loop, mainly the four type of the sub topics are nothing but the back pressure, choke packet, implicit signaling as well as the explicit signaling. So here, and I already completed the routing algorithms along with the congestion controlling algorithms by this type of concept video. At the final of this video, the students can able to learn and what do you mean by a congestion and how the congestion will be taking place and what are the type of algorithms which should be predetermined to control the congestion methods. Those should be arrived while transferring the data packets from one node to the another node by means of a leaky bucket algorithm as well as the token bucket algorithm, and mainly what are the advantages and disadvantages while we are using the leaky bucket algorithm, and apart of that leaky bucket algorithm how they will introduce the token bucket algorithm, and apart of that mainly the two controlling techniques, what we can call it as a open loop controlling technique as well as the closed loop controlling technique. Under those techniques, and again, and I have already described and discussed the retransmission policy. That means sending the packets whenever there should be not getting the acknowledgement. Acknowledgement policy means those did not have or those did not receive up to that acknowledgement. That means not reach to the destination. They did not get that acknowledgement. Admission policy, while sending the data packets from a one source router, window policy as well as the discarding policy. Coming to that closed loop, back pressure and the choke packet and the implicit signal as well as the explicit signaling. Mainly, and I thought this video is purely related for the congestion controlling algorithms and the congestion controlling methods and the techniques which should be useful while you are working with the data transmission of the packets from one source to the another node. Thank you and keep watching for my second video. Thank you one and all.
Like, share and subscribe. Hit the bell icon for more updates.